Hi everyone, this video will be a continuation of the IGCSE chemistry topic of stoichiometry. In this video, we will be discussing how to calculate the empirical and molecular formula of an unknown compound. Let us start with what a molecular formula is. The molecular formula of a compound is the actual number of atoms of each element in a molecule of that compound. For example, for water, its molecular formula is H2O, which tells us that one molecule of water contains 2 atoms of hydrogen and 1 atom of oxygen. The molecular formula of a compound is often the information that chemists want to find for an unknown chemical. On the other hand, the empirical formula of a compound is the simplest whole number ratio of elements in the compound. It is not the actual number of atoms of elements in that compound. So why would we want to calculate the empirical formula of the compound? Why wouldn't we just directly calculate the molecular formula of the compound? This is because the molecular formula of a compound is often derived from the empirical formula of the compound, and it is the empirical formula that is experimentally determined. Once we have the empirical formula, we can experimentally determine the relative molecular mass of that unknown chemical. Now, with the empirical formula and its relative molecular mass, we can now derive the molecular formula of that compound. To summarize, in order to work out the molecular formula of an unknown chemical, chemists would use chemical analysis techniques to work out the empirical formula and the relative molecular mass of that chemical. Using a combination of the empirical formula and the relative molecular mass, chemists can now derive the molecular formula of that unknown compound. Let's say we have an unknown chemical and we have experimentally determined it to be made out of 92.3% of carbon and 7.7% of hydrogen by mass. Further, we have also experimentally determined that its relative molecular mass is 78. How do we find out what is the identity of this chemical? To know its identity, we have to find its molecular formula. And as we discussed earlier, to find its molecular formula, you first have to derive its empirical formula. Let us first tabulate the information that we already have. We know the percentage of element in this compound by mass, so let's write that down. Next, let's work out how much out of a total of 100 grams do each constituent elements make up the compound. We can choose any number of grams, but if we choose 100 grams, it simplifies calculations because the mass of each constituent element out of 100 grams is exactly the same as the percentage because the percentage is also out of 100. Now that we have the mass in grams, let's work out the number of moles. We can work out the number of moles by dividing the mass in grams by the relative atomic masses of carbon and hydrogen. Next, we work out what is the simplest whole number ratio of elements in this compound, and we do this by dividing the number of moles with the smallest number of moles. In this case, we're dividing each number of moles with 7.69, which is the smaller of the two. So 7.69 divided by itself is 1. 7.7 divided by 7.69 is approximately 1. This means that the simplest whole number ratio of carbon to hydrogen in this compound is approximately 1 to 1. From here, we can work out the empirical formula of this compound. The empirical formula of this unknown chemical is C1H1. We have not worked out what the molecular formula of this compound is yet, but it will be a multiple of C1H1. Now that we have the empirical formula, we need the relative molecular mass of this compound in order to derive its molecular formula. The relative molecular mass of this compound is already given in this question. We can see in the question that the relative molecular mass of this compound is given at 78. To derive its molecular formula, we first have to work out what is the mass of its empirical formula relative to the mass of its molecular formula, which is 78. The relative molecular mass of the empirical formula is the mass of carbon, which is 12, plus the mass of hydrogen, which is 1, which gives you 13. The relative molecular mass of the compound is 78, and that's given in the question. Next, we need to work out how many times heavier is the molecular formula compared to the empirical formula, and we do this by dividing 78 with 13. which gives us 6. This tells us that one molecule of this unknown compound contains 6 of the empirical formula of C1H1. In the final step, we multiply 6 with the subscripts of the empirical formula. The subscripts of the empirical formula in this case are 1. So we multiply 6 with 1, which gives us 6. So the molecular formula of this unknown compound is C6H6, which is an organic compound known as benzene.